Okay, so here is the solutions to this written assignment number 3. So to start off with, we're just looking at some calculator things here that you want to make sure that you know how to do. So let's see, this one you're supposed to be finding a degree answer. So the first thing you'd want to do is you would want it to be in degree mode. Okay, so I'm going to take my calculator in degree mode like this. Just be sure you get that switched over. And then what this problem is saying is you're finding an angle. Okay, the unknown is the angle. So what you're going to do is you're going to do the inverse sine of this number like that, and you just do that straight on your calculator then. So I just go inverse sine in degree mode, and then I put in the value, which is 0.5863909. That'll give a degree answer, and then we just round that off to the 10th of a degree. So it looks like that one should be that answer right there. Okay, so I'm going to continue with the next one here, which is done exactly the same way. You're just going to go inverse tangent, put in your number 2.0404315. Okay, and then just press enter. And that looks like that is about 63.9. So that one should be answer D like that. Okay, so you want to know how to do inverse trig functions on your calculator without any problem. Okay, the next things you're going to do is you're going to look at working these two out without using your calculator. So this one, the key thing on this is when you're doing an inverse tangent, what this problem means is you're looking for the tangent of some angle that's equal negative square root of 3. Now I'm going to put that over 1, and remember the definition of a tangent is y over x. So what I'm going to go ahead and do is I'm going to just draw a picture, just a little graph. Whoops, that's not what I meant to do. So I'm going to draw a graph. Okay, like this. And the thing is, there's several things you want to really pay attention to on this. First of all, the range of the inverse tangent falls between, in degrees, we're trying to get degree answers on this, between negative 90 degrees and 90 degrees, which means that you're either going to be, from 0 to negative 90 in quadrant 4, or you're going to be from 0 to 90 in quadrant 1. So you're not going to be in any of those two quadrants. Well, if you look at this, we have a negative value, so that means you have to be in quadrant 4. Everything is positive in quadrant 1. So what I'm going to do is I'm just going to draw a reference triangle in this quadrant. And it doesn't have to be drawn to scale or anything, so I'm just going to draw a triangle, go straight up to the x-axis. You always go to the x-axis. And then it goes like this. Y is going to have to be negative square root of 3 because you're in quadrant 4. X is going to be 1, and then R is going to be 2, so you have a special triangle. Opposite 1 is 30, opposite the root 3 is 60, so you have a 30-60 right triangle. So there's your angle right there, but it has to be negative since you're in quadrant 4, and you have to fall within this range. That's the reason that's the answer to the problem. Okay, right, the next one we're going to look at basically the same way. What this problem means is it means find the cosine of an angle that has a value of 0. Okay, now I'm going to put that over 1, and the definition of a cosine is x over r. So that's going to go like that. Again, I'm going to draw a picture on this and try to reason out where this happens. So basically, the place, you got to pay attention to this again. The range of an inverse cosine in degrees is 0 degrees to 180 degrees. Okay, so that means you're going to have to be from there to there. You can't be down there. Okay, the only place that x is equal to 0 from here to here is right there. Okay, and that would be at the point 0, 1 if you let r be 1, like in a unit circle. So that angle would then be 90 degrees. So that's the answer to the problem. Now, both of these two problems could be checked on your calculator, but if they come from special values or a special triangle, you want to reason them out in your head. Okay. All right, so that'll take care of that. Let's go to the next page, another one like that. This one, the meaning of this problem, again, is the sine of what angle alpha is negative 0.5. Well, you know, hopefully, that negative 0.5 is really negative 1/2. Okay, the range of an inverse sine in degrees is from negative 90 degrees to 90 degrees. It's very important you know that because your answer can only fall within those two numbers. So again, what I'm going to do is I'm going to draw a triangle. And again, I'm either, since the range is negative 90 to 90, I'm either here or I'm there. Okay, I can't be there because I'm ranging from negative 90 to 90. So I'm going to give a negative answer if I'm down there, and I'm going to give a positive answer if I'm up there. Okay, well, the definition of a sine is y over r. So y is negative, so that means you have to be in quadrant 4. Okay, so we've concluded that, which is a key thing. Now we just draw a triangle. So I'm going to draw a quadrant 4 triangle straight up to the x-axis. And we just need to process what these values are. Y is negative 1, r is 2, and then that leaves x will square root of 3. That's a 30, 60 right triangle. So opposite the negative 1 is 30. Opposite the square root of 3 is 60. So this is your angle right there. But again, you have to fall within this range, see? So you must give me that angle right there. Okay? You have to pay attention to that. Okay? All right. So that will take care of that then. So let's move on to a right triangle problem and kind of go through how to do these things here. So what I'm going to do on this one is I'm just going to start by sketching out a right triangle. Okay, and the right triangle doesn't really have to be drawn to scale or anything, but you do have a naming convention. You've got to remember that the right angle we use gamma for. Gamma is the Greek letter. Okay, then we're going to have alpha and beta. It doesn't matter which is which. I'll call that alpha and I'll call that beta. Okay, so beta was given in this problem as 35.5 degrees. Okay, and then the other thing they gave us was C. Now remember, the sides go like this. So opposite alpha is side A, opposite beta is side B, and opposite gamma is side C. So we were given C is equal to 2.6. So we're going to find the remaining parts of the triangle. Okay, so step one, what I would do is I would start probably here. That's real easy to do. These two angles always add up to 90. In a right triangle, since that's already 90, all three angles add up to 180 in a triangle. So alpha is just going to be 90 minus what beta is, so 35.5 degrees. Okay, and you can do that in your head, or you could use your calculator if you wanted to on that. So I'm just going to crunch out 90 minus 35.5, and then that'll give us the first angle. Okay, so that's going to give alpha is equal to, what's going on here, 54.5 degrees. Okay, so that would be our first thing we need to find. Okay, second thing is let's find a side. Now, one of the things I like students to do is just only work with what I gave you. Okay, that way if you happen to just make a bonehead mistake on this alpha, you just did it wrong or something. I shouldn't say bonehead. I should say careless or conceptual or whatever. So the thing is, you're better off to use what you were given. Okay, so what I'm going to do is I'm going to look at this. I have an angle and I have opposite, and then I have hypotenuse. And the trig function that is opposite over hypotenuse is the sine. So we'll say the sine of 35.5 degrees is side opposite, which is B, over hypotenuse, which is 2.6. And then you can solve this proportion. You can always do it this way if you want to, just cross multiply. So B times 1 would be B. That would be equal to 2.6 multiplied by the sine of 35.5 degrees. So want to make sure you're in degree mode. It's, always check the mode that you're in. That's always really important. So we just go 2.6, and then we're going to multiply that by the sine of 35.5 degrees. And then that will give approximately, it looks like about 1.5 So that will give the second answer of the problem. Okay, so now we got that. All right, so that leaves us with one more part. We need to find A. There's more than one way to do this. You could do the Pythagorean theorem now that you know C and B. What I'm going to do is just trig. So if you look at what I've been given here, if you look at the angle and talk it out, this is the side adjacent. This is the hypotenuse. So the trig function that is adjacent over hypotenuse is the cosine. So I'm going to do this problem like this. I'm going to say cosine, again, of that angle. Do this like this. Okay, so I'm going to have cosine of 35.5 degrees is the side adjacent, which is A, over the hypotenuse, which is 2.6. If you put that over 1, you can cross multiply and do the same thing. So that's A equals 2.6 cosine 35.5 degrees. Okay, then crunch that out. Okay, so what we're going to end up having is 2.6 times, let's see, cosine 35.5. And that will give the answer. So we'll round off to 1 decimal. That looks like about 2.1. Then that'll put it all together. Okay. All right, so let's see what answer this is. Let's see, what have we got? We got 54.4, 1.5, 2.1. That appears to be answer C. Okay, that's how you would do the right triangle problem on that then. Okay, moving to the next problem. This is a word problem. So the key is to set this up, read the problem, see if you can draw a picture of it. So this says, at an altitude of 3,100 feet, the engine on a small plane fails. Holy crap. Okay, what angle of depression is needed to reach an airport runway that is 3 miles away by land? Wow, they're lucky there's an airport nearby. So round the answer to the nearest tenth of a degree. So trig to the rescue. Here's the idea. Here's your plane. Up here, engine just crashes. Okay, it looks for that runway. So right now, according to this problem, you have an altitude of 3,100 feet. Okay, and then it says you're looking for the angle of depression. So here's your airport. Okay, and it says that it is, by land, it is 3 miles away. So this thing right here is going to be 3 miles. Now, one thing you ought to pay attention to is we kind of got to disconnect in our units. So you're going to have to pay attention to that. Now, the next thing is the angle of depression. Now, what happens is if the pilot, if his line of sight is parallel to the ground, okay, that's like his eyeball and his line of sight, okay? So the angle of depression, you got to be real clear on what that angle is it's this angle right here. So I'm going to call that alpha, okay? Well, there's a well-known theorem in geometry that says these angles are equal. See, these two lines are parallel, therefore these things that we call alternate interior angles, and that's a nice thing to know in this class. The alternate interior angles are going to be equal. Okay, so what you have now is you have this angle. If you kind of look at what we have this angle, and we have a side opposite that angle, and we have a side adjacent. So we're going to have to use the tangent of alpha, since that's its definition. So there's really two things you got to do. The first thing you got to do is you got to convert these units. Now I'm going to take the miles to feet. Now you could also take feet to miles. It doesn't make any difference. So if I have 3 miles, and if I want to convert that to feet, you have to do it like this. We know that there's 1 mile. There is 5,280 feet. If you live in the Colorado, the Denver area, you are required to know, because after all, we are the Mile High City here. So what we're going to do is we're going to just multiply those two numbers. So we have 3 times 5,280. And let's see, that will end up giving us about 15,840 feet is how far that is. So I'm going to just cross that out and write that as 15,840 feet. Okay, now we're pretty much ready to wrap this up. So if we form our trig ratio, we're going to have the tangent of alpha is equal to side opposite, which is 3,100 feet, all over 15,840 like that. Now this one you have to use the inverse on, so when you put this in your calculator, you're just going to do the inverse tangent of 3,100 over 15,840, then we'll round that off. Okay, so I'll go ahead and put this in the calculator, so it's just second tangent. You go 3,100 divided by 15,840, and then we'll round that answer off. Okay, so that is about 11.1 degrees is what we're going to get then. Okay, so that looks like the answer to that problem is going to be choice A. Okay, so that's how you would do that. So thanks to trigonometry, the pilot was able to save him and all of these passengers. Thank you, Trig. Okay, next problem. All right, let's see what we got going on this one now. So this says from the edge of a 1,000-foot cliff, the angles of depression to two cars in the valley below are 21 and 28. How far apart are the cars? That's a real interesting problem. You can kind of indirectly measure how far apart things are just from some simple measurements. So let's see, to start with, this is going to be our cliff, which is 1,000 feet. Okay, then we're going to have two cars somewhere on the ground, and we're going to find that distance between the two. Okay, so first of all, we're looking at angles of depression. So remember, you got to look at parallel to the ground. This is your line of sight. So there's your eyeball. You're looking straight this way. These two lines are parallel. Okay, so if you put this together now, here's how it goes. So what you'll end up having is two angles of depression, and you got to reason out which one is which. Okay, it's pretty logical which is which. Okay, so it says the angle of depression of one of them is 21. Well, that would be this one right here. And then this whole thing, now see, the key thing is that whole thing is 28 degrees like that. Okay, so we have those two angles right there. You got to be real clear on which is which. Now, this problem could be done in several ways. The way I'm going to choose to do this is I'm going to find this big distance right here, and then I'm going to find this small distance, and then the big distance minus the small distance should be what D is equal to. So we could do trig because there's two right triangles. You have to assume that's a right angle. So you're going to have a small triangle and a big triangle like this. So I'm going to sketch them out as I go. Let's start with the big triangle. Okay, the big triangle, what you're going to have is you're going to have this angle there. Now this is alternate interior angle. So the thing that you got to be careful about it with this is 21 right there, and that's 28. Okay, you got to be real clear on which is which in there. Okay, if that angle's 21, that's 21. If this whole angle's 28, that's 28. So you would end up having 21 there, 1,000 there. And what you're going to try to find is you're going to find this distance here, which I'll call x. So if you talk it out, what you have is opposite over adjacent. So that's a tangent. So what we're going to do is we're going to solve the equation tangent of 21 degrees is equal to opposite 1,000 over adjacent x, and then we can solve that by cross multiplying. So that would give x times tangent of 21 degrees is equal to 1,000. You could now divide both sides by tangent of 21, so you'd have x equals 1,000 over tangent of 21. Okay, and then you can go to the calculator to do that then. So I'll just go 1,000 and then divide by tangent of 21. Okay, and then we'll round that off, and that's going to give this distance is about 2,605.1 feet. Okay, now see that what that is that's the big distance. Okay, Now we're going to repeat this for the small triangle. Okay, so the small triangle, what you're going to have is you're going to have this. You're going to have 1,000, a right angle, and then you're going to have 28. And you're going to be finding that distance, which I'll call y. And this is exactly the same thing. You're going to say, basically, you'll say tangent of 28 degrees is equal to side opposite 1,000 over side adjacent y. Okay? And then you can put this together like this. Now, you can do this in your head if you want to. You got y is equal to 1,000 over tangent of 28 if you solve that equation. You know, run through the steps if you have to. Okay, so what I'm going to do is I'm going to do 1,000. And then this time it's going to be divided by tangent of 28 degrees. So let's see, that would be 1,880.7 feet. Okay, so here's what we have now. See, what we just did is we found the big distance, which is this, and then the small distance, which is this. So if we subtract the two, we should be good. So all we have to do the final answer, so I've really done 3 steps. I've done those 2 distances, and then the third thing I'm going to do is just do 2,605.1 feet minus 1,880.7 feet. Whoops, I missed a 0 there. And then we'll just do that on the calculator, and then that should give us a good solution. And we'll see if that matches up. So I'm going to go 2,605.1 feet minus 1,880.7 feet, and that's going to be about 724.4 feet. Look at that. Okay, so there's your final answer right there. Perfect. Okay, these are fun problems. They're awesome. Okay, let's do a couple of things on the calculator then. We're going to use a calculator. So I'm going to just show you what you would do on these 2 problems right here. Now this one you've got degrees, minutes, and seconds on this. There's 2 ways you can do this. You want to be in degree mode. That's important. So we've been in degree mode. Okay, so what I'm going to do is just go sine, and here's the first way to do this, is just go 9 plus 30 out of 60, because there is 60 minutes in a degree. So if you do it that way, that's going to give this answer then right there pretty clearly. Okay. The other way you could do this is like this. You could go sine, you could go 9 second apps to get the angle menu to come out, and then just put the symbol. Then 30, same thing, second apps, option 2 to get the minute symbol to come out like that. Then that'll give, of course, the same answer. So it's kind of up to you which way you do that. Okay, next problem is radians. Okay, so if you're in radians, and it's not because of the pi, it's because there's not a degree symbol. So what you'd have to do on this is, the first thing is you'd have to change your your calculator to radians. Okay, like that. Now we're in radian mode. And then you would just go cosine 21. I would just use the pi key. And then divide by 8. And that should give the answer. So that looks like that one would match up with this one. Okay, so that should be the answer to that problem then. Okay, all right, so you want to be real clear on how to, of course, do stuff on your calculator. Okay, next thing I want to look at is how we would do something like this. Okay, so this is usually the way I teach this is like this, is you want to know where different things happen. So the sine of alpha is less than 0. We're looking where that's negative. Well, the sine's y over r. So the only place that happens is where y is negative. So that's going to happen there. Okay, so you can rule out those 2 quadrants there. Okay, then you have the tangent is positive. So if the tangent of alpha is positive, the tangent's y over x. So it has to occur either where you have positive over positive or negative over negative. So you would be either here or there. Those are the 2 places where the tangent's negative. Therefore, you would end up in this problem in quadrant 3. So that's how you would reason that out. Okay, the next problem is pretty similar, and it goes like this. Okay, what you would have is you would have the cosine of alpha is less than 0. Okay, the cosine's x over r, so where x is negative is there and there. X values are negative to the left. Okay, that would take care of that. So that means you can't be here and you can't be here. I've already narrowed it down to a 50-50 chance. Okay, so we got that. Okay, next thing is the cosecant being less than 0. So the cosecant, we're looking for where it's negative, so that's r over y. So y is negative down here. See, r is always positive. So you would be there or there. So once again, just by coincidence, you would be in quadrant 3. So that's how you do that. Okay? Okay, let's see. Next page, what I want to look at is how to use triangles on this. So we want to look at this a little bit. Okay, so first of all, pi over 4. Pi is 180, so 180 over 4 is 45 degrees. Okay, so what I'm going to do here is we're going to draw a reference triangle. We're in quadrant 1. So what I'm going to do is just draw a 45-degree angle. You always take your reference triangle straight to the x-axis. So you have a 45, 45 right triangle. The sides go 1 for x, 1 for y. Hold on. That's pretty bad, Brad. Okay, let's do that again. Okay, let's do x is 1, y is 1, r is equal to square root of 2 like that. Okay, that's for 45, 45 right triangle. So what we get is the secant of pi over 4, by definition, is r over x. So what you would do is you would just take r over x, and that would give the answer. So that's square root of 2 over 1. Therefore, square root of 2 is the answer to the problem. Okay? Okay, next problem, same basic idea. If you have pi over 3, pi is 180. You have a 60-degree angle, so you just need to look at a quadrant 1 angle. All right. So what we're going to do with this one then is we're going to look at it like this. Just draw out a 30-degree angle. Okay, you go straight to the x-axis like you always do. So you have a 30-60 right triangle. Okay, and it goes like this. You want to find x, y, and you want to find r. Okay, well, opposite 30 is 1. Opposite 60 square root of 3. R is equal to 2. So that's the key. So this one, you're doing the tangent of pi over 3. By definition, the tangent's y over x. So that means you would have 1 over square root of 3. And then you would need to rationalize that denominator. So if you multiply by square root of 3 over square root of 3, you're going to get square root of 3 over square root of 9, which is square root of 3 over 3. Okay, so the answer to that problem would be that. Okay. Okay, let's look at some reference angles and try to kind of remind ourselves what those things are. Okay, so what we would have is if you graphed out 426, now this is bigger than one lap around the circle, so I would start by doing 426 minus 360, and that would be 6, and let's see, that would be, I think, 66, wouldn't it? Okay, so it's a 66-degree angle. So what happens is, you're going more than one lap around the circle, like this, and you're going to end up at 66 degrees. Okay, and what a reference angle is if you take a triangle straight to the x-axis, then you're looking at that angle right there. Well, clearly, that angle is 66 degrees, so that means the reference angle is 66. Okay, remember a reference angle always falls between 0 and 90 degrees. It's always an acute angle. Okay, it's always between the x-axis and the radius. It's always that angle there. Okay? Okay, next problem. The way I would approach this one probably is, since this is a negative angle, what I would do is I would just add 360 to it. And if you do that, you're going to end up getting negative 51 degrees. Okay, so let's draw a picture of this angle. And what it is, of course, you would start at the x-axis like you always do. And this time you would go clockwise. Okay, so you'd go one complete lap clockwise, but then you would go 51 degrees more. So you would end up being in quadrant 1. Okay, well, again, a reference angle is always between the x-axis and the radius. It always is. So you're looking at this angle right here. And remember, it's always a positive acute angle. So that means that angle would have to be not negative 51, but positive 51 degrees. So that would be your solution. Okay. Okay. Now the next thing we're going to do is we're going to do some reference angles at particular points. So what I'm going to do on this was I'm going to start by graphing. Okay, and if I do this, what I'm going to have is 405 degrees. So I'm going to go through and just subtract from 360 from that. And if I do that, I'm going to get a 45 degree angle. So what this problem means is you're going clockwise and then one lap. So you're going to end up having this situation right here. So you're going clockwise and one lap. So you're going to end up with a 45 degree reference angle like that. Okay, go straight down, make your triangle. So you'd have a 45, 45 right triangle. You got to know how the sides go on this special triangle. So the sides go 1, 1, square root of 2. So therefore, the sine of 405 degrees, since its definition is y over r, you're going to do this over this. So that's going to be 1 over square root of 2. Then if you multiply by square root of 2 over square root of 2, you're going to get square root of 2 over 2. Okay, so the answer to that problem would be choice A. Okay, the next one, let's go ahead and look at where we are on this. So what I'm going to do is I'm going to replace pi with 180 just to figure out where I am in degrees. 180 over 4 is 45, so you'd have 7 times 45. Okay, and I think that's 315 is where that is. I'll just double check that. 3 times 45, or 7 times 45, is 315 degrees. Okay, so I'm going to draw a picture on this, like this, and sketch it out. Okay, 315 degree angle is in quadrant 4. So I'm going to sketch out a quadrant 4 angle. So you're kind of going like that. So you need to find the reference angle. So the reference angle, again, is between the x-axis and the radius, so you need to figure out what that angle right there is. Well, all you really got to do for that reference angle is just do 360 all the way around the circle, less the 315, to get 45 degrees. So you have a 45 right triangle then. Okay, the sides go like this. X is 1. Y, you got to be careful. That's -1 since you're going down. And then R is root 2. So if you're doing the cosine of 7 pi over 4, that's X over R. So X is 1. R is root 2. Rationalize the denominator. And you're going to get root 2 over 2. Okay, so that will give choice B as your answer to your problem. Okay, next one is a cosecant. So notice this is bigger than one lap around the circle, so I'm going to start this by subtracting 360. That's going to be 300 degrees. So what we're really going to look at is we're really going to look at the cosecant of 300 degrees. That's what matters. And the cosecant is r over y. So if we can figure out r and y, we got it made. All right, so let's draw a picture on this one. Okay, just sketch out a 300 degree angle. Now what's really happening on this is you're going one lap, but then you're going to 300 degrees, which is somewhere in quadrant 4 like this. So I'm just going to sketch that out. But you know, realistically what you're doing is just you're doing one lap and then a little bit more. So it's kind of going like that. Okay, So again, your reference angle is always between the x-axis and the radius. So you need to reason out what that is, and then you need to sketch out your right triangle. Okay, so really all we got to do is all the way around the circle is 360, less the 300 is going to give you a 60-degree reference angle. So that means you have a 30-60 right triangle. Okay, so it's going to go like this. X is 1, y is negative square root of 3, r is 2. Okay, so by definition then, we would have r over y. So you're going to have 2 over negative square root of 3. You'd want to rationalize the denominator to get 2 root 3 over negative 3. So that should be the answer of the problem. Okay, right there. All right, there's your answer. Choice C. Okay, last page. Okay, we're going to just do activity with finding trig functions. So we have 8, 5. So that means I gave you x, and it means I gave you y. And they're both positive. That's a quadrant 1 point. So we're going to have x equals 8, y equals 5. We also need to find r. We do that by applying the Pythagorean theorem. Okay, so we're going to do 8 squared plus 5 squared equals r squared. So that's 64 plus 25 equals r squared. So that is 89 equals r squared. Square root both sides, you'll get square root of 89. Okay, now we just need to apply our definition. So the sine is y over r. So that's going to be 5 over root 89. Okay, while I'm at it, the cosecant is r over y. So that's just going to be square root of 89 over 5 like that. Okay, now I'm going to go ahead and rationalize a denominator. Okay, so that would give me an answer of 5 root 89 over 89. You want to be sure you put these in a rationalized form. Okay, so that would be your answer to that. Okay, next one, the cosine is x over r. So that would be 8 over root 89. And then the secant is just r over x. So that would be root 89 over 8. Okay, so that would give you the answer to the secant. And then we just need to rationalize the denominator. And you can do that in your head if you want to. That would be 8 root 89 over 89. So that would be your solution to your problem. Okay, and then finally we got the tangent and cotangent. So the tangent's x over y. Nope, stupid. Come on, Brad, pay attention. Y over x, okay, that would be, let's see, y is 5, x is 8, so that's 5/8. And then the tangent's x over y, so that would be 8/5, okay? So that's all about definitions and having, the skill to rationalize denominators and simplify. Okay, the last problem. Now let's see, this one you're given this information. You're given the sine of an angle theta is negative 7 over 25. Okay, well the first thing you got to know is the sine is y over r. So we need to figure out what x, y, and r in this problem basically is. Well, r is always a positive number. Okay, that means y has to be negative 7. Okay, so what your job is now is to use the Pythagorean theorem to find x. So we're going to do x squared plus y squared equals r squared. So that's x squared plus negative 7 squared equals 25 squared. So that's x squared plus 49 is equal to 625. You can subtract 49 from both sides. So I'm going to do that, and then we'll do square root and see what we got here. So that is 576. Okay, so that's going to be x squared equals 576. I can square root both sides. I'm going to see what happens on my calculator. I think this is a whole number. I think it's 24, actually. So let's find if I'm right. Look at that. X equals 24. Okay, so now that we got that, we're ready to put everything in our definitions, and then we'll be done. Okay, now there's one other thing that you got to pay attention to. This is a plus minus, and you're in quadrant 3. So if you're in quadrant 3, x is negative and y is negative. So you got to be careful and make sure that you put that in there. That's a key detail of this problem, and it's because you're in quadrant 3. Okay, so what we'll do now is we just apply our definitions. Okay, so let's see. We want to find, let's start with the cosine. So the cosine's x over r, so that would just be negative 24 over 25. The tangent's y over x. Now that would be negative 7 over negative 24, so that becomes 7 over 24, and the tangent's a positive value in quadrant 3. Secant's r over x, so that would just be 25 over negative 24. So write that as negative 25 over 24. That's just the reciprocal of the cosine anyway. Okay, so we got that. And then x over y is the cotangent. So that would be negative 24 over negative 7. So that's a positive value. And then the cosecant is r over y. So that's 25 over negative 7. So that's negative 25 sevenths. Okay. So then that would be your solution. Would be this then. Okay, so that should wrap up the assignment. You can look at the solutions and go over the problems that you did incorrectly.